Got a little cryptic list here. It's not in any great detail, but it's kind of how you should go through the process of finding max and mins using the Lagrange multiplier technique. Typically, when you get one of these questions, there will be two pieces of information. There will be the function, which will typically be a surface, that you're trying to find the maximum and or minimum value for. And there'll be some kind of constraint. So in this case, x squared plus y squared, y to the 4 has to equal 5. And our job is to try and find out what the biggest and smallest value for 5x squared y under the constraint that x squared plus y to the 4 must always equal 5. So I'm going to go through this question, kind of going through this little list of things to do. So the first thing you're going to do is identify who the g of x is. G of x is the letter I'm going to use for the constraint. So in this case, g of x is just going to be that guy. The simplest way to do it is just move everybody to the left-hand side. So x squared plus y to the 4 minus 5. Now, that's step 1 done. Step 2 is we're going to find the gradient of f and lambda gradient of g, and we're going to set them equal to each other. So on this side, the gradient of f, and it's going to equal lambda, the gradient of g. And the gradient of f in this case is the partial derivative with respect to x and y. And this time it's going to be lambda, partial derivative of x and y as well. Right, if you do this with respect to x, you get 10xy. And if you do this with respect to y, you get 5x squared, which is this fella. And you stick a lambda in the front. And this guy gets you 2x, and this guy gets you 4y cubed. And that's essentially step 2 done. Now, step 3 is quite cryptic. I'll go into the details here, but you match the terms together and you solve to find any of the critical numbers. So this guy and this guy are equal. So what that means is that the x component, the first component, means that this is equal to that. I'll call that equation 1. And then equation 2, the second component, is equal to 4 lambda y cubed, and that's the second component. Now, essentially what we're doing here is looking for critical numbers. Critical numbers in this type of question are just coordinates for x and y, where you should go looking for the max and min, right? The only places are going to exist are in these special numbers, which we're calling critical numbers. And of course, we have to choose a special case before we get started, and we choose lambda equals 0. And you always choose lambda equals 0 because that's one of the places where this coordinate thing, this critical number, might hide. So this means 10xy is 0, and this guy means 5x squared equals 0. And if you're saying y 0, 4 times 0 times anything is still 0. 2 times 0 times anything is still 0. Now, when I look at these two equations, would you agree that this one tells me that x has to be 0, right? That's the only way that can happen. And if x is 0, right, if you go up here, what can your y get? Well, in this case here, y equals 0 comes out as well. So all we got out of this was that 0, 0 is a possible, well, it's a critical number, and it's a possible place for this guy to be its maximum or minimum, subject to this constraint. And then you basically deal with the situation where it is not 0. So when, oops, these are for next questions. So when lambda is not equal to 0, and I'm just going to rewrite these two equations again, we are trying to find the solution, the x's and y's, where this is true. And the algebra that you do here is essentially divide these two, and it's equal to divide these two. Now, if you take this guy and you divide them, you're going to get 2, and x is going to cancel, so you're going to get that. And if you divide these two, the trick about the dividing is it gets rid of the lambdas. And just to remind you, the reason why we had to do this lambda equals 0 here is that you're not allowed to divide these if lambda was 0. So I took care of what would happen if it is 0. Now I'm saying, I know it's not 0, I'm making it not 0 at least. And what do I get? I get an x over 2y cubed. So far, so good? Now, what you want to do here is rearrange this information so that you can tell me what x is or y is in terms of the other variable. And so if I do a little cross multiply, I get 4 times y to the 4 is equal to x squared. And I now use the boundary guy again, because he, along with this, is going to tell me who x and y is. Now, in this particular case, since it says x squared plus y to the 4 equals minus 5, couldn't I take x squared plus y to the 4 minus 5, oh, by the way, equals 0? Then I could say x squared can be replaced by that guy. So I'm basically rearranging this. And that gets me that guy, which in turn allows me to find y. Would you agree it's plus or minus 1? Agreed? Now, if I take y equals positive 1, then 4 times 1 to the 4 is x squared, which means x squared is 4, which means x is plus or minus 2. So when y is 1, x could be plus or minus 2. That generates 2 more critical numbers. If I then do y equals negative 1, I get 4 lots of negative 1 squared equals x squared, which ends up being the same thing. And so I end up with x is plus or minus 2. And what that gives me is x is 2, y is negative 1, and x is negative 2, and y is negative 1. And that is us got 2 more critical numbers. So what we've managed to do here is find the only 5 places that you need to look to find the maximum or minimum value of the function subject to that constraint. Can I pause on that for a minute? Are we good with this process? I know there's a fair amount happening. Are we good so far? Okay, so all I need to do now is plug and chug, which means it's really laborious, but it can be done. We take every single one of those critical numbers and we find the value of the original function, which is this guy, at those points. So I got a 0, 0, and then the other 4 are 2, 1, 2, negative 1, oops, sorry, negative 2, 1, actually 2, negative 1 happens next, and finally negative 2, negative 1. And that's the 5 critical numbers. And if you plug it in here, nothing. 5 times 2 squared plus 1 is 5 times 4 times 1, I make that 20. 5 times that one is also 20. 5 times this one is negative 20. Put that one in, negative 20. Provided I've calculated these correctly, isn't the maximum value that this expression will be subject to the constraints is 20, and won't the minimum value be, in this case, negative 20? And if I was being asked to, couldn't I, in fact, even tell you where those maximums and minimums happened? For instance, you'll get a maximum value for this expression of 20 at the point 2, 1 and at the point negative 2, 1, and you will find those guys are on this curve. They're on the restriction. So there is a flow to how you do these guys, right? And that flow is basically these 4 steps that I have here. Have we any questions before I do? I'm basically just going to do as many as I can in the short time that we've got. I think the more of these you see, I think the more comfortable you'll be with the process, right? Because there's a lot of similarities in each situation. Right, so I do have a whole load of them. I had them out, and here they are. So my next guy is like question 4. Here is the function we're being asked to find the max and min for. That actually looks like the guy just did. No, slightly different. X to 4 plus 3y to 4. Ah, they're 4s this time. This was a square. So we got this guy. So if I was looking at who my g of xy is, I get it from here. And that would be x to the 4 plus 3y to the 4, take away 1. Now I'm going to find this guy and make it equal to that guy. Differentiate with respect to x, differentiate with respect to y, equals lambda. Differentiate with respect to x, differentiate with respect to y. That sets up 2 equations. The first one is this guy, and the second one is that guy. First one I should do, shouldn't I check lambda is 0, right? The special case, what solution do you get when lambda is 0? Would you agree that that makes 4x nothing and 12y nothing? So don't be surprised if the origin comes out very often out of this. Right. So the origin is a possible choice. What I should have done, and I forgot to check in the last one, but does the origin, is it on that curve? And the answer is no, it's not. So I'm killing it. I should have killed. I don't know. I might not have killed the last one. Now, if you call this equation 1 and equation 2, we can divide them. And that divided by that gets you x over 3y. And that divided by that gets rid of the lambda. And it gives me, I believe, x cubed over 3y cubed. And then if I cross multiply, I get 3xy cubed is 3y x cubed. So far, so good. Okay. Now, I want to, you don't know what you're going to get till you get it. And I want this guy to somehow to be written down as x in terms of y or y's in terms of x, so that I can then plug it into this constraint here. Is there anything that you can do here that might help you out? Algebraically, is there anything you can see that you could do here? Okay. How about that? Is there any common factors that I can suck out of the left-hand side?
3yx.
And if I do that, I believe you're left with a y squared take away an x squared equals 0. So far, so good. Right, now, I think there's going to be a heck of a lot of possible versions of this. So, oops, that's for the next time. Couldn't you get y equals 0? Wouldn't y equals 0 work? Now, if you take your constraint function, which is that guy, and you make y equals 0, you should be able to find what x's go along with that combination. And the x's that go along with that combination are x to the 4 take away 1 is 0. And that's x to the 4 equals 1. And that gets you plus or minus 1. So I'm looking at 1, 0 and negative 1, 0, right? There's 2 critical numbers. Okay, that's y equals 0. Can I also do x equals 0? Wouldn't that solve this equation? X equals 0. Now, if I do x equals 0 and I plug it into the constraint, won't I find the y values where that works? And I apologize for zooming through these, but you know, you can go back and look at the video when you've got more time to kind of, you know, mull it over and see what's going on. In this case, would you agree it's 1/3? And so y would be essentially the 4th root of that guy. Yikes. And it'll be a plus and minus. So I'm looking at 0, 1 over the 4th root of 3, and 0, -1 over the 4th root of 3. Little side issue. Can you imagine I plugged x equals 0 in here, right, in a different world? Let's pretend that for argument's sake, it was this guy, right? Just pretend for a minute it was this guy, right? And I got x equals 0. I would end up having to solve this. Wouldn't this mean then that x equals 0 does not generate any answers? So you just throw it away, right? Because you won't be able to get a real value for this. So sometimes you're going to plug in an x equals this or a y equals that, and the other coordinate doesn't exist as a real number. Well, that just means x equals 0 doesn't work, right? Doesn't matter what you pick, it ain't going to work. We haven't finished with this, believe it or not, because we still have this one. And isn't this one going to happen when x squared equals y squared? Agreed. So let's see what that looks like. We're going to make x squared equals y squared, and we're going to do it for x to the 4 plus 3y to the 4 minus 1 equals 0, right? That's our constraint. That one's so symmetric, it really doesn't matter which one I'll do it. So I'm going to do it to this guy. Won't that be y squared squared? Plus 3y to the 4, take away 1. And so that becomes y to the 4. And that means plus 1 over the 4th root of 4 and minus 1 over the 4th root of 4. And for every single one of these little darlings, isn't there going to be an x with it? So let's take this fella. If y is 1 over the 4th root of 4, then since x squared is y squared, x squared is going to be 1 over the 4th root of 4 squared. That makes x squared 1 over the square root of 4, which bang on turns you back into the 4th root of 4. So you end up with symmetry. So we are going to get, trust me, 4 more answers. You're going to get a positive 1 over 4th root 4 in both cases. The first one's going to be positive. The next one's going to be negative. Both of them are going to be negative. And last one is what? A negative first and a positive last. And there's no way in the world I am going to do all 4. What was it? 1, 2, 3, 4, 5, 6. That's 6 guys. Wouldn't you plug all 6 guys in? 20 minutes later, you find out one of them's the biggest and one of them's the smallest, and you're finished. Whew, I feel like I'm doing a speed trial. Okay, I'll do this one slow then. As long as it's not 8 critical numbers, I'll do it to the end. If it is 8 critical numbers, I'll cheat at the end. So here is our function, and here is the constraint. So we're going to identify g of x, y, and z this time. And it's 4x squared plus 4y squared plus 7z squared minus 39 equal to 0. And we're going to find this guy and lambda this guy. Oops. Lambda this guy. That guy gets you 8. That guy gets you 8. This guy gets you 7. you're going to have lambda. This guy gets you 8x, this guy gets you 8y, and this guy gets you 14z. That sets up 3 equations. Let's do the special case, lambda equals 0. If lambda equals 0, don't we get a contradiction?
Yeah, because we'll have a number equals 0, which that's just not math.
Right, and can we kick out lambda equals 0 as generating any critical number? And let's pretend that we managed to get it, and the chances are it'll be 0, 0, 0, because 9 out of 10 times it ends to be the origin. When I then check, does it satisfy this guy? In this case, it doesn't, so I would kick out for that. So the lambda equals 0 special case, 9 times out of 10, it never gets you anybody you use, but you have to check for it. Because there's a 1 in 10 time that it does get you a guy that you can use. And isn't Murphy's law, the one time you didn't bother checking was the one time you should have, right? So you may end up doing every single one of your homework questions, and all of them except one, that didn't generate any critical numbers. Now we're looking at 3 equations here, and there are 3 variables. So we know that the critical numbers now are going to be a 3-dimensional coordinate, right? An x, a y, and a z, right? Because it's moved up 1 dimension. I'm still going to do the division technique. I'm going to take 1 and divide it by 2. And if you take 1 and divide it by 2, you get 1. You divide that by that, and you get x over y. And doesn't that just generate the relationship that y should be equal to x? Are you comfortable with that? Now I'm going to take 1 again, but now I'm going to divide it by 2. And sometimes you take 2 and divide it by 1 if you think it's easier to deal with. But I'm doing 1 and dividing it by 2. And if I take this guy and divide it by this guy, I get 8/7 is equal to, the lambdas cancel, that's what, 4/7. And there's an x on the top and a z on the bottom. So if I do a little cross multiply, I get 56z equals 28x. And what shall I get? Z ends up being 1/2 x. Are you happy with that?
Did you mean to write divide equation 2 by equation 3?
I did. I meant to write 1 by 3. Equation 1 has the x's in it, and equation 3 has the z's in it. Are we good? Right, now, I have a constraint which is a bit messy, 4x squared plus 4y squared plus 7z squared. You can make it equal 39, I like doing it that way. And all I know right now is that y is equal to x, right? And z is equal to 1/2 x. Yet that's enough to solve the puzzle. Because what I'm going to do is replace the y with an x and replace the z with 1/2 x. And do you see what I've now got is just an equation in x's. So far, so good? Right, so 4x squared, 4 lots of x squared, yikes, 7/4 x squared equals 39. What's that? 8/32. Oh, that's going to come out nice. That's why you should use textbook questions. Isn't 34/4 what you get? And to get x squared, won't I divide both sides by that guy? And oh, isn't that elegant? You get 4, which means that x is plus or minus 2. Now, if x equals 2, won't y be the same value as x? So it's 2. And won't z be 1/2 of that, which is 1? So there's one of my critical numbers. If x equals -2, y will be the same, also -2, and z will be half of that, which is -1, and there is my second answer. In fact, they are the only two critical numbers that we have, which is much better than that horrible one I had earlier with about 10 answers. Are we good so far? Now, to finish with then, don't I evaluate our original function, which is this guy, in these two places? So I have my critical number at 2, 2, 1, and we're going to evaluate it 8x plus 8y plus 7z. So what's that going to get me? It's going to get me 16 and 16 is 32 plus 7. I'm going to get 39. Well, gorgeous. Oh, better not.
Yeah, not there.
You want to say hi to my wife, guys?
Hi.
Hello.
Hello.
Hi.
Right
Hey.
click. Yeah. Oh, and you can't hear that.
Hello.
Hi.
Hello.
I was. Oh God, my writing's a list. I don't.
So this is the person who keeps you in line, sir.
Yes. She also loves my jokes and thinks I'm really cute.
Have you
She's
heard
one
about
in a
the
million. Hang on to her.
Have you heard about the benefits of eating dried grapes?
No.
Well, I'm trying to raise I'm raising awareness.
Oh God. I have created a monster by telling bad jokes. Now it's spreading to my students. Okay.
The rumor about butter.
Oh God, what's that one going to be?
Never mind. I shouldn't spread it.
What is the fastest type of milk? Pasteurize, because it's pasteurized before you see it.
Why was the chicken kicked off the baseball team?
Why?
It was accused of foul play.
Okay, that's it. No more. We have an absolute max and we have an absolute min. We're finished, right? The question was find the absolute max and absolute min of this function subject to that constraint. Are we cool? Any questions about that one? Apart from please don't tell me any more bad jokes. Let's move on then. The majority of the questions that you're going to deal with involve that basic process, either 2 or 3 variables, but they get progressively more difficult algebraically. So you're going to have to create techniques for dealing with you know, in this one here, do you see how it just, the way it worked out? You're going to have kind of strategies for taking care of that. So let me pick 8 as my next guy on the list. And I have no idea if this one's going to be a horrible one or it's going to be pretty straightforward. You're never quite sure until you get there. My gut feeling is that this one's going to be nice. So I have, this is the constraint. Okay, so the gradient at f, lambda, the gradient at g. And this guy is 2x, 2y, and 2z. My gut feeling that this is going to be nice is, isn't there a lot of symmetry going on here? X, Y's, and Z's are very similar to each other. That makes me think that the critical numbers are going to be things like 1, 1, 1, and 1, negative 1, 1, right? Just combinations of the same number. So I hope that is what we get. In this case, 4x cubed, 4y cubed, and 4z cubed. And so when we set up our equations, we have that guy. When we set up the second one, we have that guy. And we set up the last one, we have that guy. I'll call this equation 1, equation 2, and finally equation 3. Again, are we good so far? Can I go for the special case that we have to deal with, and that is lambda equals 0. Guess what? There's not going to be a surprise here. If lambda equals 0, doesn't 2x equals 0, 2y equals 0, 2z equals 0? So we get a possible critical number of 0, 0, 0. Does 0, 0, 0 work for this constraint? No, right? 0 squared plus 0 to 4 plus 4 isn't 5. So not usable, done. I'm going to use this technique, the dividing guy. So if you divide this guy by this guy, you get 2x over 2y equals 4 lambda x cubed over 4 lambda y cubed. That becomes x over y, and that becomes x cubed over y cubed. And I believe I get x y cubed equals y x cubed. Agreed? Divide, simplify, divide, simplify, cross multiply. And I'm going to rewrite this as x y cubed, take away y x cubed equals 0. And that, if you pull out an x and y, gets you that. I'm just going to pause there and deal with that later. If you take equation 1 and divide it by equation 3, you will get 2x over 2z equals 4 lambda x cubed over 4 lambda z cubed. Because there's a lot of symmetry, it looks very like the previous question. If I then bring everything over to the left-hand side and make it equal to 0, I can pull out zx as a common factor, and I'll be left with that fella. So I'm going to put those two equations together and see how they play with each other. I know that xy times y squared take away x squared has to be 0. I know that zx and z squared take away x squared has to be 0. And whatever values of x, y, and z that I get, they have to work with the constraint, which is this guy. If you just focus on the top, would you agree that x equals 0 will generate some solutions? If you look at this one, would you agree y equals 0 generates solutions? And if you look at this one, doesn't that basically say that x should equal y or x should be the negative of y? And if we look at this one, you get x equals 0 again, but don't you also get z equals 0? And from here, don't you get x equals z and x equals negative z?
Would it just be that x equals y? Why would it be x equals negative y?
Here, well, if you take y squared, take away x squared is 0, then what you're saying is y squared equals x squared, right? And that can happen two different ways.
Oh, just because of the square root.
Yeah. And the same things for the z. So we're trying to figure out how on earth all these different combinations go together or don't. It seems like I have got quite a few things to check or test against. So my mess here, so I'm going to rewrite it again. Yeah, okay. So here is one of our two equations, right? And here is the other. And I have possible places to look. Those could be 0. And don't I also have x is plus or minus z and x is plus or minus y? That's a kind of summary of all the things that we've got, right? Now, if x is 0, it works here. And does it work here? Yeah. If y is 0, it works here. And it has no effect in that guy. So that's fine. And if z is 0, it works here and has no effect. So there's nothing particularly awkward going on right now. So I have to commit myself to some choices. If I choose x equals 0, then I get that. Agreed? If I make x equals 0, we get that. If I make x equals 0 and y equals 0, I get that. So won't you get plus or minus the 4th root of 5? Oh God, this one is going to be horrendous. Agree? Now, I'm just going to cut to the chase here. There are tons of permutations that are going to happen, but aren't all those permutations going to be some version of 0s and root 5s? So can I just tell you right now, it looks like they're going to be 0, the ugly 4th root, 0, 0 minus ugly 4 roots. I'm not doing this one. Wouldn't you have to write down 8 different things and go hunting for which one's the biggest and which one's the smallest? So ... I much prefer the answers where there's only 2 guys, because then I can go hunting for it pretty quickly. God, that's horrible.
Makes me want to use a spreadsheet.
It makes you want to use software, for sure. Lagrange multipliers are cool when the equations come out nice. Would you agree they are very clunky if you don't get very nice situations? It wouldn't surprise me if people were using this technique, would be using it along with some software. You wouldn't really want to do everything by hand. So I'm seeing if I can find another guy. No, it's just basically the same as the one I just did. Oh, goodness. See the ones that I've just talked about? There's 2, 4, 6, 8 permutations allegedly. Yikes. For our last question, use Lagrange multipliers to find 2 numbers. You'll recognize this one. 2 numbers whose product is 144, but whose sum is a minimum. So 2 positive numbers, check it, yeah. 2 positive numbers multiplied together to give me 144, whose sum is a minimum. And I'm picking this one because it's actually going to come out really nice. Does anybody here have any ideas what that answer might be?
Would it be 0 and 144?
Well, 0 times 144 gives you 0, so it doesn't work. But it would have been if it was allowed.
Oh,
12
it
and
would
12.
be negative
12 and 12 is what we're going for.
I'm
Would you
thinking
agree?
-12 and -12.
Well, it must be positive numbers, so it's going to be 12 and 12. If you allowed negative numbers, what you just said, Sally, would be correct. So I should have said 2 positive numbers. So here goes. I'm going to call the first number x, and I'm going to call the second one y. This is the constraint. Isn't the constraint that xy has to equal 144? Now, what is the function that we're trying to optimize? It's the sum. So a really nice, easy equation. And so this guy, lambda, that guy, I always want to forget the lambda for some reason. So here we go. 1 and 1. Lambda. The g of xy in this case will be xy take away 144. So when you differentiate this with respect to x, you get y, and when you do that, you get x, and you get that guy. And so we have 1 equals lambda y, and we have 1 equals lambda x. So there's our 2 equations. Again, I should check the special case. If you make lambda 0, do you agree that it's impossible? Because it doesn't work. So forget it. Now I'll take equation 1 and divide it by 2. Have you noticed that's consistent, that we just do the division every time, whether it's 2 or 3 variables? In this case, 1 divided by 1 is that guy divided by that guy. 1 is equal to y over x. So a little cross multiply. X is equal to y. It's much easier to do these questions when there's only 2 variables, because then don't you only need to find out what x is in terms of y or what y is in terms of x, whichever one is easiest to do. And since I now know that, I'm going to plug that information into our constraint. And that's going to be x times x. So x squared is 144. Technically speaking, it's a square root of 144, but since it has to be positive, do you see why I'm picking 12? And if x is 12 and y is the same as it, you can see we've now solved the problem. Oh, come on, that was nice and clean compared to some of those ugly ones, right? Those show you the benefit of Lagrange. It would get really messy. I've got a few seconds. I won't do this question, but it's just curious. I don't even know if there's an answer. I wonder if you can do it for 3 positive numbers. So x, y, and z is going to be, I'm going to pick something that is cubed, 8, right? That should be a nice answer. I'm making the prediction. Shouldn't the answer be 2, 2, and 2? Do you think that would be reasonable? We are trying to do it to maximize the sum. Right. So that's going to be my F. And if I rearrange that, now it's going to be my G. So this fella, I think I might actually be able to do this if I do it really quick. You're going to get 1, 1, and 1. That's nice. And this guy's going to be, okay, maybe not quite as nice as I thought. This guy's going to be YZ. And then you're going to
1, 2, and 4. 1, 2, and 4.
Oh, do you think it's going to be 1, 2, and 4?
It has to be if you're going to maximize the sum, right?
Oh, well, 1, 2, and 4 is going to be bigger. You're right. So it's not symmetry. Let's find, maybe there's some even better than 1, 2, and 4. Right?
1, 1, and 8.
Yeah,
1, 1,
could
and
be.
8. Could be. Maybe there's some even better than 1, 1, and 8. You know, a half, half, and 32. I don't know. Let's find out. Last one is going to be, what's the damn Z one? X, Y, that one doesn't have an X, that one doesn't have a Y, so this one won't have a Z. And so we're going to have lambda YZ, lambda XZ, and lambda XY. If I tried 0, it doesn't work. If I do my dividing then, let's see what the relationship is. 1 is equal to y over x, so that makes x equals y. 1 divided by 3 gets me 1 equals, I should be careful with this in case I screwed up here. Yeah, okay. If you do these two, don't the y's disappear and you get z over x. And z over x, if you cross multiply, says x equals z. Okay. And so I'm going to be able to take x, y, and z equals 8 and call it x times x times x equals 8. Ah, that's interesting. X cubed is equal to 8. The best number to use is actually the cube root of 8 for all three numbers. Interesting. I wonder if, let's just check it out. 8 to the power of 1/3. I have just found the minimum answer that you can get. So the question up here would be find 3 positive numbers that have the product of 8 and whose minimum sum is x plus y plus z. Because if you do that, the answer is 2, 2, and 2. And doesn't that only add up to 6? And don't we already had some examples that beat 6, right? So when you find a critical number, aren't you finding the biggest or the smallest? And since there's only one solution and it's clearly not the biggest, doesn't that mean it must be the smallest? So can anybody think of a combination of x, y, and z that multiply and give you 8 that add up to less than 6? And I bet you the answer is no. Interesting. Yeah, that makes sense. So theoretically then, doesn't that mean that the maximum could be as anything you like? Because couldn't I make x a millionth?
I actually got one.
What?
Less than 6. They got to add to less than 6.
Okay,
-2 and -4.
Not allowed. Positive numbers only.
No, I know. I just.
Oh, but if you went negative, you could. But see if
Yeah,
you made
it didn't have that constraint. I was just trying to be funny.
Oh, got yours. Terence, you're nearest to him. Will you hit him for me? I mean, just bang on the screen. Anyway, if x is a million and y is a million, won't z be a billionth? And if you add them together, don't you get a billion plus? Can you imagine that the sum could be as large as your one? Right, that makes sense. Okay, Monday is a holiday. I won't see you, so don't be around. I don't think I'll be doing anything because it's my wife's birthday and we'll be having some family things, so I don't think I'll be available that day. What else? I've moved the homework to midnight Monday. Since it's a holiday, there's no reason why I can't do that. So you get an extra day to do your homework. Test 1, online test 1, will also be moved to Monday. It will be available at 2, but well, that's it. It'll be available at 2.